To question 8, this is topic B. Liquid is vaporized to a gas at constant temperature. Okay. Three quantities of the substance are intermolecular potential energy, root of the mean square speed of molecules, average distance between molecules. Which quantities are greater for the substance in the gas? Greater for gas. Okay. So this is clear. They've explicitly told us it's constant temperature, which means average Ke is equal to the same for each. There's no change. No change, right? And that's because it's average K is essentially a measure of temperature. And we have that in sort of derived formula. Ke average is equal to 3 over 2 kBT. Now this is just not considering the number of molecules because we're finding the average, so we're dividing by n. So it's n dividing by n, and that's just kBT. So knowing that, now we can say our square speed of or root of the square speed of molecules is not changing, so there can't be greater. Now our intermolecular potential energy is increasing. Our average distance between molecules is increasing. This is gas, so our particles are further apart, right? And intermolecular potential energy increases with distance, right? If we have two particles like this, there's less intermolecular potential energy. It's almost like a restoring force. And so what we have is 1 and 3 only, and that's B. On to question 9. An insulated container of negligible mass contains mass 2m of a liquid. Piece of metal of mass m is dropped into the liquid. The temperature of the liquid increases by 10 degrees, and the temperature of the metal decreases by 80 degrees in the same time. Okay, what is the specific heat capacity of the liquid and specific heat capacity of the metal? So what we can do is write our formulas. Q of our insulated container is Q2m is equal to mc delta T, right? 2m C Cm C2m. How about I just do liquid? UL is equal to CL. Delta T is increases by 10 degrees. So we have 10. And the temperature of the metal decreases by 80 degrees in the same time. So what we have is Qm M C delta T is 80, right? And so what we have is 1 over 8. Or 1 over 4. Actually, QL and QM should be the exact same, right? The energy lost by the liquid is gained by the metal. Oh, sorry, the energy lost by the metal is gained by the liquid. And so what we have is this, and we can say this is equal to 1, right? Same. So 1 is equal to 1 over 4, CL over CM. And so our actual answer, CL over CM, which is what we're trying to find, is equal to 4. And so our answer is B. Number 10. The molar mass of an ideal gas is m. Fixed mass m of the gas expands at constant pressure. Fixed mass, okay. The graph shows the variation with temperature T of the gas volume V. What is the gradient of the graph? So we have V over T. Right, and what's our equation? PV is equal to N or T, right? So V over T is equal to N R over P, right? And what is our molar mass? Our molar mass is M divided by number of moles. Number of moles, right? Take this as grams per mole. This is grams, and this is moles, right? So it works out. That's how you can break it down for yourself. And so what we want is to replace our number of moles with M and N. So N is equal to M over M, which is, sorry, this formula, M R over M P. And so our answer is M R M P. Ooh, there's two different M's. Should be D. And yeah, that looks about right. Our answer is D. 11. A traveling wave on the surface. So this is topic C. Let's move on to that later. Hope all of this made sense. Thanks guys for watching. Please drop a like and subscribe if you learned something and this was helpful.